So hello viewers and welcome back to another video on networking. So in today's video we are going to have a look at the packet formats of DNS protocol. So in last video we had covered these three topics, which is like introduction of DNS, why we need it and how it works in details. In today's video we'll go through packet formats for the DNS protocol. So without wasting much time, let's get started. So let's get started with the understanding of packet formats for the DNS protocol. Now we will start our discussion with the common format. So this is like a common format for the DNS packets according to definition that is defined under RFC 1034 and 1035. You can just go through these RFAs if you want to understand this packet formats in details. But I will just give you an overview. So this is like the common what you can say packet format for DNS protocol. Now the first section of that is like header, which is length of that is 12 octet. So this section is always present in whatever the next DNS packet that we are going to see. It specifies which of the fields are present in the packet. So out of these 4 remaining fields, what are the fields present? It specifies that over here. Also message is a query or response. Like it also specifies whether the message is like DNS query, which means a machine is asking for the IP translation for the domain, or it is a response, which is like whether it's like a response for the asked or the queried domain. So it's like if it is packet is containing domain name or the IP address of the domain. So that's like the definition defined over here in the header section. Next section is question, which is filled by the client. It includes the detail of a query sent to the server. So which domain we are querying for, that is mentioned over here in this section, which is called question. Answer, authority and addition. So these fields are returned by the server, and these are this apart from header, whatever fields that you see over here, these all 4 fields, question, answer, authority and additional, they are all variable fields, which mean the length of that fields might be variable in all the packets that we sent. Only the length of the header, which is 12 octet, which is fixed. Now we will see the packet format for the header. So now let's see that. So this is the sample packet for header, again according to the definition which is defined under RFC 1034 and 1035. First of all, we have ID field, which is identifier. The length of this field is 2 bytes. And it is used by the client to match the response with the query. So it's like an identification number for particular query. Because we can at the same time we might ask for multiple domain name queries. So that's why we have ID. So we can identify for which of the response we have this particular packet for. Now we have OP or QR, which is like operation type, which means whether we have a query or DNS query or DNS response. So according to that, the value over here will be 0 or 1. Now OP code. So query type, which means it's basically the length of this field is 4 bits, which means 0, 1, 2 or 3. This field can carry. So 0 means standard query, 1 which means DNS domain name to IP translation. 1 means inverse query, which means IP being translated to domain name. Second means server status query, which means DNS server status is fine or not. And 3 to 15 is reserved for future. So that's how this field is interpreted. Now AA. So if this bit is set, which means if this bit is 1, so it responding DNS server will be authoritative for domain name query. So that means whether the server the reply should come from the authoritative server. Now this is also these all fields are like 1 bits. So TC, if this bit is set, which means the data or the message is truncated. RD, which means resolution mode that client expects DNS server to use. Now if you remember the earlier video, we have seen the iterative mode and recursive mode, the difference between that. So the 0 means iterative mode, so that is if that represent that, and if the value over here is 1, which means recursive mode. So that's how it is interpreted. RA means resolution mode that DNS server can provide. So 0 cannot can provide. So 0 over here means it does not support iterative, it can support recursive only, and 1 which means it does not support recursive mode. So that's how it is interpreted over here. Z, which means this 0, this is like 0 bit, this bit must be 0, like the value, the length of this field is 3 bits and it is reserved for future, that's why it should be 0. R code, which means a response code, so length of this is again 4 bits. 0 means no error, 1 means query format is incorrect, 2 means server fails, 3 means domain name does not exist, 4 means query not implemented, 5 means query refused, and 6 to 15 are reserved for future. So as you can see, this is how response code should be interpreted. And now let's see these fields. So for QD count, the value over here, it's an unsigned integer, 16-bit value. So number of entries in the question sections. So it can happen that DNS request might get combined. So multiple DNS requests that we are making that can go through one DNS packet only. That's why QD means number of entries. So that can be like multiple number of entries we can send with one single DNS query. AN count, which means this value is also an unsigned 16-bit integer. So this field means number of records in the answer section. So like so this field will be filled by server. This field represent how many queries that was sent by client, and this field represent how many answers that we got from the server. NS count, which means all 4 bits are like unsigned 16-bit integers. So this field represent number of name server resources records in the authoritative section. This field is like AR count. It represents the number of resources records in the additional section. So this is how the header section is formatted, and you can get the idea from the fields and the value, size of the value, and just like that. Now let's see the question section. So yeah, QD count is equals to 1 usually here, so which means so this is like variable. So in this particular section, the number of QD count, let's say if it is 2, then we might have this entries 2 times. Here we have, let's assumption, we have made an assumption that QD count is 1, which means only we have one query. And how does the query is formatted? So first we have query name or Q name. So this is also variable length. A domain name represented as sequence of labels, where each label consists of length octant followed by number of octants. So that means the size of the Q name and the value of the Q name. So that's how it is stored. The Q type, it's like type of query, which means query type. The length of this field is 2 bytes. So 1 represents Q type is equals to A, host address. 2 represents Q type is equal to NS, which means authoritative name server. 3 means Q type MD, which means mail destination, and 252 represents AFXR, which means transfer of an entire zone. And there are some other values for that also. Q class, which means the query class, the class of query, which means like in what class the query falls. So 1 means internet class, 2 means CSNet class, 3 means chaos, and 255 means any class. So this is how the query count or the query is represented in this format. This is a variable, and there's 2 others have 2 bits, and the size is given here. Now let's see what is the type for resource record format. So this is the type, and answer, authority, and additional sections all share same format. So this means answer, this NS record and AR count, they share same format. Now name means variable length, a domain name to which the resource record patterns. So the question, so the resource record, which means the server will fill this entire field, So whatever the question that we have asked, which means whatever the domain name that you are asking to translate, that will be stored for that IP address will be stored over here, and the name is stored in such a way that the first will be length of the field, and then there will be the value for the name. Second means type. So type of resource, which is like 2 bytes, meaning of the data in our data field. So this field is how to interpret, that is defined over here in the type. Now class of a data in the R data field in 2 bytes. So like what is the class for the data that is defined here, and the size of this is 2 bytes. Now TTL, an unsigned integer that specifies the period during which the resource can be cached, which means if let's say this is a recursive request, that means another server, recursive DNS server, is trying to query from somewhere else, or our machine also have the DNS, local DNS. So till how long our local DNS can cache this record, that is defined over here in the value field TTL. So which means the value 0 is equal to resource cannot be cached. So if let's say TTL is 0, that means you should not cache the answer for the query. Now RD length, which means the length of this R data, the size of this is 2 bytes. This is also an unsigned integer that specifies the length of this R data, right? R data, so this is like a string of variable size format where varies on this type and class which is being asked in the question, and also formatted here. So those value will let the end machines knows that how to represent or how to interpret this R data field. Now we have CPT demo. So I guess we'll keep the video till here. So we have seen the packet format for DNS. So this is like common packet format, and you can just grab the Wireshark, start the packet capture, and just query google.com from your browser or any other domain, and you will see every time. I am not sure every time, because there might be a cache already present, the DNS cache already present in your machine, but you might find the DNS packets, and you can just observe whether we have correct packet format visible over there or not. Next video we'll see that also, and we'll also see the CPT demo and NS followed by NS3 demo. So yeah, that's it for today's video. We'll meet in the next one, and we'll see the CPT demo. Till then, keep learning and keep exploring. Bye bye.